All right, welcome calculus class. Let's do this. What's the game plan today? We want to be able to analyze what a limit is by using a table. So let's just take a look at this first example. If we have this function x squared minus 4 over x minus 2, using this table, let's plug in every x value into this function. And to make our life very easy, let's use a calculator. So here, we want to plug in, and let's just zoom in a little bit. I want to plug in this x squared minus 4. So to do that with your calculator, a nice, easy thing to do is, let's start off by plugging it into our calculator. So we want x squared minus 4. First, we want to go to y equals, right? And let's plug in this x squared minus 4. So here, it would be parentheses x squared minus 4, parentheses close, and then divide x minus 2. Okay? And you have to be very careful that if you don't put a parentheses here, the calculator will read x squared minus 4 over x minus 2. So make sure you have that parentheses here. And you know what, just to be safe, let me put a parentheses over here too. So x minus 2. Okay? Now that the function is stored in, let's look at step 2. We want to go back to the home screen. So to do that, all we need to do is hit second mode, and now we're at the home screen. So what we want to do next is, our game plan is to plug in this 1.9. So to plug in the 1.9, what we do is, we first go to vars, which is right here, and then we go to y vars. So I hit right, and then I hit enter. Oh, whoops, I kind of skipped a step, my bad. So let's try it again. Just vars, y vars, and then here you want to go to function. Hit enter, and then you hit y sub 1, and you hit enter. Notice that this y sub 1, if I go to y equals, our y sub 1 is the function we stored. So here, when I have this y sub 1, I'm going to tell the calculator to put 1.9 into that y sub 1 function, and if I hit enter, this is the value that I get. And this should be 3.9. Okay? What I want you to do is, do this for every single one of these, and then we're going to see what happens as the limit of x approaching 2 of this function. Okay? So take your time. I'll pause the video. Been 3.9, 3.99, 3.999, and these values here. So what this is saying is that when x is approaching 2 from the left, let's look at this one here. Like when we look at this graph over here, how do we read this? This is as the limit of f of x as x approaches 2 from the left. So 2 approaching, and remember, where is this 2? It's going to be right over here, right? So let's just, when it's approaching 2, notice what's the y value it's getting close to? It's getting close to 4. So then we could say that this is 4. And we also know that from the right side, it's also approaching 4. And that's what these x values are saying. You see here, when we're at 1.9, which is right before the 2, here, let's zoom in a little bit. When we're at 1.9, right before the 2, you're getting very, very, very close to 4. And here you're getting very, very close to 4. And this is from the right side. So here, notice that in the blue, these values show that you're going from the right side, and in this pink, these are the x values that are being showed going from the left side. Notice that it looks like it's getting very close to 4, but when I try and plug in 2 over here, let's take a look over here. If I go vars, y vars, enter y sub 1, and I plug in 2, what happens? It says you can't, oh, sorry, I had the calculator here. It says you can't divide by 0 once you plug in 2. So here, this is undefined, okay? Undefined, or it does not exist, okay? So then you see the limit, when you go from the left side, it's going to 4. The limit as going from the right side, it's going to 4. And so the limit is going to 4, right? But when I plug in 2, it's undefined or does not exist. Does not exist, right? And here, it's not shown in the picture, but there has to be an open hole here. Okie dokie. So notice that even if we didn't have the visual, using a table, we were able to figure this out. What I want you to do is, let's try and do the next one together, okay? For this one, what I want you to do is, let's plug this function in, this x minus 3, let's see, this one here, this x minus 3 over x squared plus 2x minus 15. So what we're going to do is, we're going to go to our y1 equals, we're going to erase this, right? And then let's plug it in. So parentheses, x minus 3, parentheses close, divide, parentheses open, x squared plus 2x minus 15, parentheses close, and then we hit what? Second mode, right? And now we're at the home screen. So what I want you to do is I want you to plug in every single one of these values, and let's see what happens as x approaches 3. And notice, over here we don't have a graph, we don't have a visual. But that doesn't mean we can't figure out these values, okay? And again, that when I'm approaching from the left of 3, these are my x values. So these x values are talking about this limit over here. These x values over here mean I'm coming from the right. So these x values mean I'm coming from the right. Let's see if they both converge to the same point, to the same y value. Okay, so take your time and plug in the y values. Let's see what happens. As you're approaching 3 from the left, notice that these values look like they're going to 0.1250. And it looks like it's going the same way over here, that if I were to do like 3.001, let's just try that again, 3.0001, like that. Let's just see what happens. So let's go to vars, y sub 1, parentheses, 3.000001, close. Notice that it's getting very close to 0.125, right? So this is 0.125, and that's the same. So notice that it's approaching the same thing, but at x equals 3, it doesn't exist, okay? So here, because the limit is approaching 3 from the left, I'm sorry, it's approaching 1.250 from the left, it's approaching 1.250 from the right, so then this limit must be going to 0.1250. But at x equals 3, it does not exist. Now let's see, in the last example, I forgot to explain why over here at 2 it did not exist, right? So let's just look at this real quick. Notice that here, for the denominator, we can't have 0 in the denominator. And what can x not be over here? X cannot be 2, because if I plug in 2, the whole denominator becomes 0. Well, let's look at this one over here. For this rational function, here, the top we're not so concerned about right now, but if I try and factor the bottom, how does the bottom factor? It's x minus 5, x plus 5, x minus 3. So here, x cannot be minus 5, and x cannot be 3. Okay? And that's why this does not exist will happen when we plug it in. And notice that we did this all without a visual. But let's take a look at what the graph looks like. So here, let's see. Over here. If you want, you could go to Desmos, and that's what I've been using, and this is what the function looks like. This x minus 3, this is what the function looks like. And notice that, remember that x cannot be minus 5 and x cannot be 3. So x cannot be minus 5 and x cannot be 3. Notice that because at this minus 5, this kind of asymptote exists. So x cannot be minus 5. But here at x equals 3, which is over here, notice that it looks like there's a hole and it's filled. But in reality, at 3, it's undefined. There is a hole over here, and it exists because if I plug in 3 in the denominator, then the whole denominator becomes 0. So, yeah, okay? Very good. Let's try and do the next one, which is this one over here. So for this graph, now this will be a very interesting graph. What I want you to do is, same idea. What I want you to do is plug in these values, okay? Plug them into the calculator and see what happens, okay? And for this one, something very strange will happen, but go ahead, go for it. Here, notice that these are the values, and just in case if you didn't get them, make sure that you plugged it in properly, right? It should be 2x, here, let me change the glare here, and then don't forget the parentheses, right? And this is how it should have been plugged in. But for here, let's take a look. These are the x values that are being approached from the left. These are the x values as you're being approached from the right. And notice that they're not matching, right? And don't think for a second that, I mean, not don't think, but notice that it keeps getting bigger every time you get very, very close to 2. Let's try another one again, that if I put in, let's say if I try 1.9999999, let's put in 7 nines. So if I could do this, let's say if I go vars, y vars, and I put in 7 nines, 1.1234567. Here, the number just keeps getting bigger and bigger and bigger. So notice that it doesn't go to a number the closer I get to 2. Here, it's going to negative infinity. This, from the left side, it's going to negative infinity. From the right side, the numbers are getting so big that it's going to positive infinity. So here, the limit does not exist because you can't, this is the rule of the infinities, that because they're both going to infinity, limits must go to a real number. So here, at 2, it does not exist. Now, we need to look at what this graph looks like. What I want you to do is go to Desmos, and then if you want, go to Desmos real quick and see what this graph looks like. And let's see what it looks like. So here, this is the graph. Notice that, and let's compare it with the table. Here, hold on. You see, like, notice here that as you're going from the left, what happens to the values? It's going to negative infinity. It's going all the way down. Notice that when you're coming from the right, it's going to, oh wait, we're going to which value? We're going to 2, sorry. So because we're at 2, right, we're looking here, that these values are going to negative infinity. When I'm approaching 2 from the right side, they're going to positive infinity. And here, they'll never reach 2. It'll be very, very close to 2, but it'll never reach. And that's the idea of these limits. Okay? I hope this helped. And notice that if I were to show you this graph and I said, what's the limit of 2 from the left side? You would say negative infinity. What is it from 2 from the right side? It is positive infinity. But notice that we didn't need the graph to be able to figure that out. We just needed to plug in values that got very, very close to 2. And that was the whole idea of this lesson. What I want you to do is try and do the back page by yourself, this x cubed minus 1 over x minus 1. And here, notice that I didn't give you x values. Try and do it yourself and see where the limit goes just by plugging in numbers. Okay, I hope this video helped.